We are building the Hungry Traveling Snake project from the YBite Python curriculum available at www.ybite.in. In the previous video, we saw how we could use the t.distance command to figure out if my snake head is getting too close to, say, a piece of food, and hence I say that these two are overlapping now and I can deem that the food has been eaten. In general, the t.distance command gives us the distance in pixels between two turtles, say turtle S and turtle T. Strictly, this is the distance between the centers of these turtles, much like in Scratch. If I were to do a compare and contrast, the distance to, let's say, a certain sprite in Scratch is exactly same as this, as we will see in a little bit more detail. Now, in our case, remember, we are converting our snake head as well as the foods to squares. And it turns out that when I do that, in fact, both of them are squares with 20 pixel height and 20 pixel width, let's say. So 20 pixels on each side. How do I know this? Well, I'll demonstrate this to you later. I used a method called t.getShapePoly, which gives me the vertices of these squares. Now let's just spend a little bit of time trying to sort of understand how the distance works and see what the distance value is in certain scenarios, because this will, number one, help us understand the function better. Number two, make us much more comfortable about our game when we want to adjust these thresholds later on. And number three, in general, distance calculation involves Pythagoras theorem, and hence it's quite interesting from a mathematics point of view. Let's say these two completely overlap. Remember, the distance function is giving me the distance between the centers between the two centers. Hence, I'll get distance will be exactly equal to 0. We'll see this later. Let's say there's half overlaps, which means I have 50% overlap. I've moved one of those two away. I will see distance as 10, and this is again expected because, like I said, the pixel width is actually, the turtle width is actually 20 pixels. If these two are just about touching, the distance is 20. And if these two are, let's say, placed the way I have placed them, the distance is about 28, slightly more than that, because by Pythagoras theorem, if this side and this side are both 20, the diagonal has to be 20 times root 2, which is actually about 28, slightly more than 28. Now let's see all this in action because that makes it more clear. Like I said, in this video, we'll just explore the distance command a bit more carefully. In the next video, we'll see how we can use all this understanding to decide the thresholds for the distance that we must set to determine if the turtles are coming too close to each other. But here, for the demonstration's sake, I've started turtle. I've created a shape. I've created a turtle called A, converted the shape to square, and I, like I said, use get_shapePoly to get the vertices of this turtle. Notice it's 10 minus 10, 10, 10, minus 10, 10, minus 10, minus 10, which tells me that each side of this is actually 20 pixels. In fact, we can verify this also. Let's say I create another turtle. I will just say, okay, B, which is, say, another turtle. And again, just like our snake head or say the foods, I'm going to convert this shape into, say, a square. Now, I'm going to also color this B to, let's say red color, so that, I can distinguish between the two. And I'm going to put the pen up for B because I'm going to move this B, say, away from A. Let's say at this point, I find the distance between these. As expected, the distance between them is actually going to be 0. And that's exactly what I see. And that's not a surprise because they are completely overlapping. Let's say I move my B a little bit. So I say B dot forward, let's say 10. Now, expectedly, the distance will become 10 because, notice there is now exactly half the overlap. Let's say I move this further and I take it, let's say, another 10 steps further. Notice these two are now just about touching. They're adjacent to each other, and hence the distance that I measure as expected is 20. Now let's say I move my B, say, upwards. So I go and say B dot set heading, let's say 90. So now B is going to move upwards, and I'm just say B dot say forward, by say 10 steps. At this point, the distance between these two is something like 22.23, which is actually more than 20. That's quite interesting. We'll see the significance of this later. But let's say I go and further move B forward. This is the situation I've shown you. These two kept side by side by Pythagoras theorem. I know that the distance should be about 28 something, and that's exactly what we see. Like I said, do these experiments, perhaps try to convince yourself why these numbers are coming this way. And that will be a very nice exercise in mathematics. We will come back to this observations a little bit later and see how this becomes useful for us in our snake game. I hope you found this useful. In general, if this way of learning, where we are applying concepts all the time, where we are reasoning out things and understanding how they work, if this thing works for you, look at our website, because that's how we learn Python. Take care. Thank you so much. Bye bye.